All right. Well, I hope everybody's having a good day. We are going to continue talking about law of sines and law of cosines today. In fact, we'll talk more about law of cosines than anything else. We have a few problems for review on the law of sines. But the only thing I have to mention, tomorrow's the end of the 6 weeks. So if there is any exam or quiz that's still within the time limit left for you to retake, it has to be done by 4:20 this afternoon. So also, if you haven't turned in your focus activities, again, you have until 4:20 because tomorrow I'm going to come in first thing, take care of the points in the point bank, and then just go ahead and submit all the grades. So if you need anything, both Mr. Yacht and I will be here after school until 4:20. Okay, let's get going. So we started talking about the law of sines yesterday, but we're going to use the law of sines and the law of cosines, thank you, on what we call oblique triangles. What does that mean? None of the sides are equal? Well, now that we could call scalene, but I'm talking about this triangle does not have a particular angle measurement. There you go. So we're talking about triangles with no 90-degree angles. So we're either going to have 3 acute angles or we're going to have 2 acute and 1 obtuse. Now, in order to use the law of sines, you had to have what we call a pair, an angle measure and the side length directly opposite that, because all you're going to do is set up a proportion. The sine of angle A over side A equals sine of angle B over side B equals sine of angle C over side C. And then we did several problems that people seem to be doing pretty well on. And this is where we stopped yesterday. Okay. Is there anybody who still needs a minute to go ahead and copy that down? Okay, good. Let's just get right to it. A person in a hot air balloon observes that the angle of depression to a building on the ground is 65.8 degrees. After ascending 500 feet, the person now observes that the angle of depression is 70.2 degrees. How far is the balloonist from the building? Okay, so the first thing I'm going to do is just kind of put together a little sketch of the scenario. And there are several items here that we're just going to have to assume in order to make the problem work. So just kind of go with it. So let's say we have an individual in a balloon right here. Okay. My amazingly detailed hot air balloon. So from this person's line of sight, let's say that line of sight is parallel to the ground, okay, the horizontal. So we're looking down at the building. So let's just say looking at the corner of the building. We have an angle of depression of 65.8 degrees. Okay. So then what's the balloon do? It goes up. Okay, it ascends. It rises. So it goes up 500 feet. Okay, now we have the balloon again. There we go. Now from the new position, again comparing the line of sight, looking straight down at the same location, we now have an angle of depression 70.2 degrees. Okay. So we can see the triangle that I'm going to go ahead and work with. Let me see if I can recreate it over here. All right, so we have this is 500 feet. Okay. Now, from this line of sight, we knew that this exterior angle right here was 70.2 degrees. So what would this inside angle be right here? What's complementary with that? And what's the key word I said there? Starts with a C. Complementary. So that means 2 angles that add to 90. So basically, what's 90 minus 70.2? 19.8. So this is 19.8 degrees right here. Now, let me go ahead and kind of fill this in for just a minute. Here's where the balloon originally was. This was the person's original line of sight. So that this was your 65.8 degrees. Well, we're going to go ahead and say that the balloon went straight up so that it creates a right angle with the line of sight. Because we're going to say the line of sight is parallel to the ground. Okay, so if we knew that this one portion was 65.8, and I know that's a right angle, well, what's the obtuse angle in that triangle? There you go. 90 plus the 65.8 gives me 155.8. So let me go ahead and erase this because otherwise there's going to be way too much going on in that triangle. Okay, so this angle right here, 155.8 degrees. Okay. Well, we have 2 of the 3 angles, so we can easily go ahead and figure out this smaller one. Remember, the interior sum was 180, so somebody help me out. 180 minus 19.8 minus 155.8. Okay, 4.4. So this angle right here is 4.4 degrees. Now, ultimately, all we want, how far is the balloonist from the building? So we're talking about this longest length right here. All right. Now, we are able to use the law of sines because by finding that last angle, we did give ourselves a pair. We have the 4.4 degrees and we have the 500 directly across from it. So I'm going to go ahead and say sine of 4.4 degrees over 500 equals. Now, if I'm looking for side x, well, what angle measure am I going to use? It's got to be the 155.8. I need the angle measure across from the side we want. So sine of 155.8 degrees over x. Remember, law of sines was just a simple proportion. You just needed an angle measure and the side length across from it. And how do we solve a proportion? I forget. Cross multiply. Okay. Now, one thing we started getting in the habit of yesterday was just writing out the expression for my unknown. So what's in the numerator? 500 sine 155.8, and then to be over sine of 4.4 degrees. There we go. So this should be able to give me the distance that I'm looking for between the individual and where we were looking at the building. Okay. So if I come on over here, let me get rid of that. Okay, control divide. What was that? 500 sine of 155.8. And then we were dividing that by the sine of 4.4. Okay, so what distance should I be looking at if I push enter? Okay, 2671.6. 2671.6, and we're talking feet. There we go. Okay, questions? Not too bad, right? Okay. All right. Well, I got one more problem. Okay. Now, this one we didn't have time to copy. If you don't want to copy the entire thing, we could just go ahead and copy the diagram right here. Let me go ahead and highlight these. Okay. But the problem says a tree is leaning 10 degrees past the vertical, as shown in the figure. A wire that makes a 42-degree angle with the ground 10 feet from the base of the tree is attached to the top of the tree. So how tall is the tree? Okay. So take about a minute. Try to figure out the height of the tree. We're talking in feet here, based on this diagram. I'll put that right back up there. Oops. There we go. Okay, now we don't yet have a pair in order to use the law of sines, but we can easily find the remaining angle, which would give me a pair. Okay. All right. Anybody want to come on up and show me what they did? Okay, Natalia? All right. I mean, how many opportunities are you going to get to say you came up and taught next to the Joker?
Since once in a lifetime.
Once in a lifetime. There you go. Or if you want to use red, you can. It is Halloween.
Okay, so first you have to find that one. So
Okay.
42 is like
38 degrees. Okay.
So then you can set up your proportion with sine
Bless you.
8 over.
Okay. Mm-hmm. Okay.
Just go to
10 times the sine of 42 divided by the sine 38 degrees. Everything looks perfect. Okay, she just hasn't evaluated that. Anybody want to help her out?
2.9.
So it's like 10.9. Yeah, okay. So 10.9 feet. Perfect. There you go. That's all there is to it. Is anybody having trouble with the law of sines? Anybody confused? Easy? Super easy. All right. Good, good, good. Well, let's talk about Law of cosines. So you're going to have a different type of triangle here. You're either going to be running across typically side angle side, or you're going to have side side side. Okay, the point is you won't have a pair. You're not going to be given an angle measure and the side directly across from it, so you won't be able to use law of sines yet, even if you wanted to. Now, I did say yet, but here are the three versions based on the three different sides we have. So the one thing I want to point out at the beginning, it's a little larger, but it's still just as easy to work with, whether you're trying for an angle measure or a side length. I do want to show you in the beginning that whatever side length you start your equation with, you end with the angle directly across from that. So if I start with side A, I end with cosine of A. Start with side B, end with cosine of B, and so forth. Now, it's the same pattern no matter what your vertices are going to be named. You'll notice the other two side lengths, you always square them. You take the sum, then you go ahead and subtract 2 times their product, and then, of course, times cosine of A. All right, the pattern holds through for all of these. So let me go ahead and give you just a quick example. Let's say I had an oblique triangle, X, Y, and Z. So this is side Z, this is side X, and this is side Y. Okay, what I want you to do, take about 15 seconds, write out the law of cosines if I started it with Z squared. Okay, because it doesn't matter what variables you're using, it's just the pattern that you have to remember. Okay, and again, I hate to use the word memorization, but okay. So in this triangle here, if I wanted to write the law of cosines, starting with side Z. Okay. Well, the other two sides are X and Y, and if I follow what I see here, the first thing I should do is square both of them, add them up, then subtract what? 2 times X times Y times the cosine of what? Angle Z. There you go. So it does not matter. And a lot of times you're going to run across triangles that maybe don't even have names, or that are going to be something different from ABC, and don't let that throw you off. Okay, well, let's just get right to a problem. First example. It says a triangular area of lawn has a sprinkler located at each vertex. If the sides of the lawn are 19, 24.3, and 21.8 feet, what angle of sweep should each sprinkler be set to cover? All right, so what I'm given is a triangle side, 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 and all I want to do is find the three missing angles. Okay, so let me go ahead and draw myself a triangle here. Again, I tend to draw my oblique triangles pretty much the same. So this is A, this is B, this is C. Let me go ahead and a little more room here. Now let's see, across from angle A, that was the 19 feet. Then across from B, that was the 24.3 feet. And then side C was the 21.8 feet. Okay. Now, we're not going to be able to really get into it today. It'll be tomorrow when we talk about this. But in this type of problem, when you have side, 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 I would strongly encourage you to always start with the largest angle first. Okay. Always start by finding the largest angle. Now, quick explanation. We are either dealing with 3 acute or we have 2 acute and 1 obtuse. And we need to know if that 1 is obtuse, because he will change things, and you'll see tomorrow. But how am I going to know which of the 3 angles is the largest? Yeah, remember the characteristics from geometry. The largest angle is always opposite the longest side. So in this case, what am I looking for? I want angle B first. Okay. Angle B is across from the longest side, 24.3. So I'm going to take the information I have, and I'm going to go ahead and just plug it directly into my law of cosines. So I'm going to start with side B. So 24.3 squared equals. Now remember, what do I do with the other two side lengths? Okay, I add them after squaring them. So I'm going to say 21.8 squared plus 19 squared minus 2 times their product. So 19 times 21.8. And I'm going to end it with cosine of what? There you go. We started this law of cosines with side B, so I'm going to end it with angle B. Okay. So what I'm trying to do is work backwards and figure out the angle. So there's another concept we're going to have to remember in just a moment. But my main concern now, we need to go ahead and isolate cosine of b. I need to push everything else to the other side so that I can go ahead and evaluate that. Now, only one class has taken me up on this so far. Would anybody like me to show the steps in between, or can I just kind of talk about it and go to the expression? Does anybody want me to show moving those items over? You do? Okay, I will do it. Now, the first thing you're going to want to do, the individual terms, you're going to want to go ahead and subtract those over. Okay, so I'm going to have 24.3 squared minus the 21.8 squared minus the 19 squared, because if you want to get something to the opposite side, you have to perform the opposite operation, equals negative 2 times 19 times 21.8 times the cosine of angle B, right? So now I want to go ahead and divide by that product coefficient. I want to divide by this whole product right here. So I'm going to divide by negative 2, 19, 21.8, and then over here, negative 2, 19, 21.8. Because anything divided by itself is going to cancel. See, now I know that cosine of B equals this ratio. Okay. Now, let me go ahead and find the value of this ratio first, and then I want to ask you a question. So let's plug this in the calculator. Come on over here, document B out of this. So we're starting with 24.3 squared minus the 21.8 squared minus the 19 squared, all divided by negative 2 times the 21.8 times the 19. Okay. Now this is what cosine of B should equal, right? So let's go ahead and say 0.2967. Okay. So cosine of B equals 0.2967. Now, I'm not going to use that rounded version. I just went ahead and rounded it so I could show work on my paper. Okay. Now, here's the thing. Think all the way back to when we first started trig. What am I going to input into a trig function? What do I plug in? What are considered my x values? Angles, whether they're degrees or radians. So I plug in an angle measure. What does this decimal represent? A ratio of what? There you go. The ratio of side lengths of a triangle, right? Now, if I have that ratio, but I want the angle measure, does anybody remember what I do? We got to take the inverse. That's right. So in this case, I'm going to take cosine inverse of 0.2967, and that should give me the angle measure I'm looking for. Okay. When you're looking for the angle measure, that's when you take the inverse sine or inverse cosine, whatever trig function you have. But again, I'm not going to use this rounded version. When I come on over here to my calculator, I'm going to go ahead, pull up cosine inverse, but I'm going to use my touchpad. I'm going to highlight the previous one, and then that's what I'm going to input in there. I'm going to use the exact value. It's going to give me a much better outcome. So let's say that angle B, let's say 72.7 degrees. Okay. All right. So 72.7 degrees. Now, does anybody notice it? Well, it is acute. That's true. So I know that all three angles here are going to be acute, but do I have to continue using the law of cosines? I don't have to do that anymore. I've given myself a pair. Now, because this is our introduction, I'm going to go ahead and use the law of cosines again, but I want you to see I can immediately revert back to the law of sines because of what I have here. Okay, so let's go ahead and find another side. Let's go ahead and go to A. All right, so I want to find angle A. Can anybody go ahead and tell me what the law of cosines would be given the information? What would I start the equation with? Okay, what's that? Okay, 19 squared equals. Because remember, we're trying to find angle A here. 21.8 squared. 24.3 squared. There you go. Okay. Now we just want to do the exact same thing we did a moment ago. I need to get the ratio that equals cosine of A. Now for this one, I'm just going to go ahead and immediately go to it, just like we started doing it yesterday. Can anybody tell me what should go in the numerator? What should start it? 19 squared plus, oh, minus, okay, 24.3 squared. And then what's going to go in the denominator? The negative 2, 21.8, 24.3. Now, I'm also going to go ahead and do something different than what I did just a moment ago. We know that cosine of angle A is going to give me this ratio, whatever it turns out to be. So instead of finding that and then plugging it in, I'm going to do this. I'm going to go ahead and say cosine inverse. I'm going to go ahead and plug that ratio just in directly. Okay? Whatever you feel is best. Okay, completely up to you. So in this kind, we had 19 squared minus the 21.8 squared minus the 24.3 squared, all divided by parentheses negative 2 times the 21.8 times the 24.3. Okay. So what am I getting for angle A? Okay. 48.3. 48.3 degrees. There we go. And now, do we even have to go ahead and use either a law of sines or law of cosines to find the remaining one? No, we can just use simple subtraction. Okay. Now, I'm going to go ahead and use the values in the calculator, and it's ultimately really not going to make a difference, but 180 minus the first angle B we found, minus the angle A we just found, okay, and 58.95. So I would go ahead and say what? 59 degrees, because look at how you rounded it here. Okay, the 0.7 plus the 0.3 will give you 1 degree, right? Okay, there you go. And that is the law of cosines. Anybody not sure about anything I did? Any questions? Easy? Okay. All right. Well, let's go ahead and try this one. It says a triangular lot has sides of 120, 186, and 147. So another side. Find the angle across from the shortest side. Okay, so this one isn't labeled directly, so I'll just go ahead and say A, B, C. So let's say we have 120 feet here, we have 186 feet here, and we have 147 feet here. Okay, so the way I created my triangle, okay, which of the three would be the smallest angle? Would it be A, B, or C? Why C? Yeah, because it's across from the shortest side. All right, so I want to go ahead and figure out what's the measure of angle C. All right, so walk me through this. What would I do? What would I write down? I'm sorry? 120 squared. Okay. Now what? Equals. So 186 squared plus 147 squared. There we go.
Why are we starting with the smallest one?
Oh, just because this one, it just says find the angle across from the shortest side. So this one, we're actually not doing like the previous problem where we're going to find everything. This one was very specific about what we want. Now, if we were to go ahead and find everything on this one, I would absolutely start with the largest. So I'd go ahead and start with A. Okay. Again, I'll show you why that is tomorrow. Sine inverse has a couple of issues with it. Okay, so let's go ahead and write out cosine of C. Okay, what's the numerator? I heard 120 squared minus 186 squared minus 147 squared. What's my denominator? And there we go. So cosine of some angle has got to give me this ratio. So cosine inverse of the ratio should give me the angle. Okay, so let's come on over here, document B. Okay, cosine inverse. Okay. So 120 squared minus 186 squared minus 147 squared, all divided by, parentheses, negative 2 times 186 times 147. Okay. All right. So what is the smallest angle of this triangle? There we go. Perfect. That's it. That's law of cosines. Anybody having difficulty? Anybody not understanding? Any questions?
Um, can one of those legs be
Could one of those legs be what?
like a negative and then make the angle look like it?
No. Now, the only reason we have, like, say, negative lengths in the unit circle is because that's telling you the direction. So we're not saying that the length is actually negative itself.
Oh.
Because it just doesn't make sense the way we kind of view those things. Okay. Anything else? All right. Well, this is as far as the other classes got. Well, first period anyway, and then we stopped at the same spot. But I do want you to try this one. So sometime between now and tomorrow, okay, when you come in after the happy minutes, this is where we're going to start. I want you to go ahead and find side A, and I want you to go ahead and find angle measures for B and C. So let's round A to the nearest whole number, and let's say the nearest tenth for my degree measures. But you'll notice this isn't a side, side, side like we previously had. This is a side angle side. I still can't use law of sines, but you're going to notice something different when you apply the law of cosines to this one. In fact, you're not going to have to manipulate it at all. All right, you'll see what I mean when you go ahead and step to write it out. Okay. All right. Now, when everybody walked in, did everybody get a dum-dum? Okay, you did. Did you want one? Okay. If you want one, please help yourself. Now, at the end of the day, if you want to come back and get another one, I'm perfectly okay with that. I just want to make sure that there's enough for everybody today. So, absolutely, please, if you haven't grabbed one, go ahead and do so. All right. And I think that is all we got for today.